All right, this is the Algebra 1, new Unit 8, Lesson 2 video over multiplication of polynomials. So we're going to go through a variety of examples. I'm basically covering all the types of problems that are here in the lesson as well as in the problems you actually have to work out. So I'm going to work through them kind of in the same order, and it kind of builds in difficulty as you go through the lesson. So I'm going to do about 10 problems, and they're going to be the different types of problems that you're going to see. So the first type that we want to look at is going to be multiplication of monomials times other monomials. So that would be something like this. 5x squared times 4x. So this is kind of important because it's kind of the foundation of everything else that we're going to do. So when we multiply different terms, in this case, each of these has only one term, we're going to multiply things, the things that are kind of the same type of thing. So what I mean is numbers are going to be multiplied by other numbers, and x's are going to be multiplied by other x's, a's by a's, b's by b's, y's by y's, and so on. So you'll see that as we go through that's kind of going to be one major thing. So in a sense, this could be rewritten as 5 times 4 and x squared times x. You don't have to rewrite it that way. I just want to kind of show you how this works. So if that were the case, 5 times 4 is 20. X squared times x, remember this is an x to the first. So x squared times x, remembering our exponent rules, is going to be x to the third. And so that would be the answer to that problem. So again, when you multiply single terms, you multiply all the like things. You multiply numbers times other numbers, and then each variable times its corresponding kind of friends in a sense. So let's look at one where we have more than two, I mean. Let's say we have 3x squared y times 3xy squared times 4xy. So again, we're going to be looking at multiplying things that are the same type of thing. So in a sense, we're going to do 3 times 4. So again, I'm going to write this out this way for this kind of first go around, just so you can see what we're doing, but you don't need to write out this step every single time. All right, so if we were to do that, 3 times 3 times 4, that's going to make 36. X squared times x to the first times x to the first, that's going to be 4x's, so x to the fourth. Y to the first times y squared times y, that's also going to be y to the fourth. So again, pretty straightforward. When you multiply single terms, you just multiply the common things. Now, in this next problem, we're going to see something a little bit different. We now have a monomial, 2a, times a trinomial, but the process works for any number of terms. So this is what we call the distributive property. That should sound familiar to you. The distributive property says when I have a number being multiplied times a parentheses, it's as if I'm multiplying that number times each one of the terms. So I'm going to multiply each one of these. Now, again, I'm going to write out every step. I don't know if you'll always need to do that. But in other words, I'm going to multiply the following three things. 2a times a squared plus, that plus is coming from there, 2a times 3a minus 2a times 6. And so when I go through that, 2a times a squared, that's going to be 2a1 times a the squared, that's a to the third, plus 2 times 3 is 6. a1 times a1 is a squared, minus 2 times 6 is 12a. So you can see with the distributive property, you multiply that first number times each term. Another example of one of those, let's go and do one more. Let's say I have 4x times 3x squared minus 2x plus 1. Again, we're going to go through this and we're going to multiply each number times 4x. So again, being very thorough, 4x times 3x squared minus, it's coming from there, 4x times 2x plus 4x times 1. Let me work out each one of those. 4 times 3 is 12. X1 times x2 is x to the third. Minus 4 times 2 is 8. X1 times x1 is x squared. And then 4 times 1 is 4x. And we're done with that. All right, let's keep moving. So that would be the end of where we have a monomial times polynomials. So what comes after this is going to be problems that we call the FOIL method. Use what we call the FOIL method. So the FOIL method is a way of multiplying binomials times binomials. So let's say I have this. Excuse me. Just going to drag this. The FOIL method stands for the following. F, O, I, and L stand for first, outside, inside, and last. And it refers to the different pairs of numbers in this expression. So first would be the first term from each parentheses. Outside would be the outside terms. Inside would be the inner terms. And then last would be the outer terms. So let's look at how that plays out. So for first, I'm going to do x times 3x plus outside x times 4 plus 2 times 3x plus 2 times 4. 2 times 4. And then I go ahead and do each one of those, work it out. X times 3x is 3x squared plus 4x plus 6x plus 8. And then I do combine like terms, if possible. And that, in this case, that means I'm going to combine these terms. So it's going to be 3x squared plus 10x plus 8. So just to kind of go back, I did the first terms, the outside terms, the inside terms, and the last terms. In a sense, I'm distributing the x, and I'm distributing the 2. Now, there were no negatives in this, so let's look at an example where there are negative numbers involved. Let's say I have a minus 2, a plus 3. Okay, we're going to use FOIL. So we're going to do first times first. That's going to be a times a. And we're going to do outside, a times 3. Inside. Now, this is where, because there's a negative on this 2, I'm going to make that a negative when I multiply it. So it's going to be negative 2 times a. And then negative 2 times 3 for the last. So this is first, outside, inside, last. Let me go ahead and work it out. A times a is a squared. A times 3 is 3a. Negative 2 times a is minus 2a. Notice I just dropped this and brought the negative down. I'm going to do the same thing here, minus 6. Just drop that negative and drop that positive and bring the negative down. Then we combine like terms, and we get a squared. 3 minus 2 is 1a minus 6. You don't have to write the 1. Your answer could just look like that. All right. Let's do a couple of more examples. Make sure I get my numbering right here. I think I'm on number 7. Yeah, 5, 6, 7. Okay, number 7. Let's say we get one that has some coefficients. Let's do 2x minus 1. Oops, sorry about that. 3x plus 6. Now I'm going to kind of go through this one a little bit more quickly just so I can kind of talk through maybe a slightly faster way to do it without writing out the entire step. But when I do these, I'm going to do 2 times 3x. It's going to be 2 times 3 is 6. X times x is x squared. So what I'm doing there is I'm skipping this step. I'm just going right to the answer. 2x times 6 is going to be 12x because 2 times 6 is 12. X is by itself. Then I'm going to do minus because there's a minus on that 1. Minus 1 times 3x is minus 3x. And then minus 1 times 6 is minus 6. Now I'm ready to do combine like terms. 6x squared. 12 minus 3 is 9x minus 6. All right. And let's do one more. Let's say I have 3x plus 4 and 3x minus 4. All right. Well, when I do 3 times 3x, it's going to be 9x squared. 3 times 3 is 9. X times x is x squared. 3 times 4 is 12x because it's negative on the 4. It becomes negative down here. 3x times negative 4. Remember, always use the sign that comes before the number you're working with. Then we have 4 times 3x. That's 3 times 4 is 12x. And then 4 times negative 4 is negative 16. Now we're ready to combine like terms. And we get 9x squared. And then look, these cancel out. Leaving me with 9x squared minus 16. All right, I'm going to add a new drawing for the next one. All right, so I think we are on to number 8 now. Now, it's going to go up yet another level. And in this level, now we have 2 terms times 3 terms. And really at this point, it just comes down to staying organized. So make sure that you are going through this systematically, and I think you're going to be just fine. So in this problem, I'm going to do 4x times each of these terms, and then I'm going to do 5 times each of these terms, keeping track of my negatives the entire time. So there's going to be 6 answers after the first step. So let's go through and see what this comes out with. 4x times x squared is 4x to the third because there was an x1 and an x2. 4x times 2x is 8x. 4x times 6 is 24x. And I missed a squared on that second term. Let's go back to that. 4x times 2x is 8x squared. Then 4 times 6, x. Then we go minus 5 times x squared. That's 5x squared. Minus 5 times 2x is negative 10x. Negative 5 times 6 is negative 30. Well, now we're ready to combine like terms. So we go through and we try to find things that are the same term. Let's see. The 4x to the third is good to go. Then we have x squareds right here and right here. 8 minus 5 is 3x squared. Then we have, I can use a different color here. Oh, that's the same color. Sorry about that. X's here and here. 24 minus 10 makes 14x. And then last but not least, negative 30. comes down. So that would be the final answer. So really, once you get to this upper level of multiplication, it's really just a matter of keeping organized and making sure you've done all the multiplications that you have to get the answer. All right, 2 more examples. These examples should mirror pretty closely what you're seeing on your lesson. C squared minus 2, C squared plus 2C minus 7. All right, so again, I'm going to go through, I'm going to distribute C squared, and I'm going to distribute 2. So I'm going to have 6 answers. C squared times C squared is C to the 4th. C squared times 2C is 2C to the 3rd. C squared times minus 7 is minus 7C squared. Negative 2 times C squared is negative 2C squared. Negative 2 times 2C is negative 4C, or just C. And negative 2 times negative 7 is plus 14. Once again, I go look to combine like terms. C squared is by itself, or sorry, C to the 4th is by itself. C to the 3rd also has no pair to go with it. So that's going to be 2C to the 3rd. I do have negative 7C squared and negative 2C squared, which is going to make negative 9C squared. Minus 4C is by itself. And so is 14. And that would be the final answer. So in that case, only those 2 terms in the middle actually did combine like terms to get there. All right. And then it kind of builds to this final kind of level, which is 3 terms times 3 terms, which is really just more steps. In this case, it's going to be 9 different things. So let's look at an example. 3x squared minus 2x plus 1 times x squared plus 4x plus 3. So again, we're going to have 3x squared times everything. Then we're going to have 2x times everything. And then we're going to have 1 times everything. So let's do those each separately. So 3x squared times x squared is 3x to the 4th. 3x squared plus 4x, that's going to be 12x to the 3rd. 3x squared times 3 is 9x squared. Actually move this over so we have plenty of room. Then looking at our blue terms, negative 2x times x squared is negative 2x to the 3rd. Negative 2x times plus 4x is negative 8x squared. Negative 2x times positive 3 is negative 6x. And then lastly, in green, 1 times everything is just going to mean the terms are going to come through the same. 1 times x squared, 1 times 4x, 1 times 3. Now it's just a matter of finding your like terms. I see that there are like terms here and here. I see that there are like terms for x squareds there and there. I see that there are like terms for x's here and here, and the other terms don't have anything to go with it. So let's bring all that together. So I'm going to end up with 3x to the 4th. Then my 12x squared, or x to the 3rd, and my 2x to the 3rd are going to come together to make 10x to the 3rd. Then my x squared terms are going to come all together, and they are going to make 9 minus 8 plus 1. That's going to be 2x squared. And then my 6x and my 4x are going to come together. That's going to make minus 2x plus 3. Organization is the key here. As you go through the problem, just kind of make sure you're getting every single combination done. But that is what you need to get through lesson 2 of our lesson, of our unit. And there are 2 sections of this, so make sure you complete those. But that is it.